Hello, my dear bacho. I know, exams are just around the corner, and you're all studying so hard. So, let's do a quick revision of one of the most important chapters, triangles. And don't you worry, we're going to make it super simple and fun.
You know, have you ever just looked at a massive mountain and thought, how on earth do they even measure that? I mean, you can't exactly take a giant measuring tape up there, right? Well, the secret to solving these huge problems is hidden right here in this chapter. And the one magic word that makes all of this possible is similarity. Yep, this single, simple idea is the key to everything. So let's figure out what it actually means. Okay, first things first, let's get this perfectly clear. When we talk about something being similar in maths, it really just means one thing. They have the same shape, but not necessarily the same size.
Now, you might remember congruent figures from class 9, right? They were like identical twins, absolutely the same shape and the same size. Well, similar figures are more like a family photo. Everyone has the same family features, the same basic shape, but they're all different sizes. That's the big difference. And look, this is a perfect example. We've got two pictures of the beautiful Taj Mahal. One's a small postcard, the other is a big poster. The shape, it's identical, but the sizes are obviously different. And that, my bachon, is similarity.
All right, now for the official rule. For any two polygons, could be squares, pentagons, anything, to be similar, two things must be true. Number one, their matching angles have to be equal. And number two, their matching sides have to be in the same ratio. You absolutely need both of these conditions, not just one.
Okay, get your highlighters out because this next one is the superstar of the chapter. This is a Pakka 100% guaranteed exam topic. It's the basic proportionality theorem, also known as the mighty Thales theorem.
Now take a second and read this statement on the screen very carefully. You should try to memorize this. All it's really saying is that if you draw a line inside a triangle and that line is parallel to one of the sides, it magically cuts the other two sides in the exact same ratio. That's it.
Just look at this diagram here. We have our big triangle ABC. Now, see that line DE that we've drawn inside? It's parallel to the bottom side BC. Thales' theorem promises us that because that line is parallel, the ratio of the top part AD to the bottom part DB is exactly equal to the ratio of AE to EC on the other side. That's the whole theorem in one picture.
So remember how polygons needed two conditions to be similar? Well, guess what? For triangles, it gets way easier. We have a special little toolkit, 3 golden rules that let us prove triangles are similar much, much faster.
And here they are, your 3 best friends for this chapter. First is AAA. If all 3 matching angles are equal, the triangles are similar. Done. Second is SSS. If all 3 matching sides are in the same ratio, they are similar. And third is SAS. If 2 sides are in the same ratio and the angle between those 2 sides is equal, then they are similar. And now for a pro tip that's going to save you so much time in your exam. You don't even need to check all 3 angles. If you can just prove that 2 corresponding angles are equal, we call this the AA criterion, the third one has to be equal anyway, right? Because the total is always 180 degrees. This little shortcut is a lifesaver.
All right, enough theory. What's the point of having a toolkit if we don't actually use it? Chalo, let's put on our thinking caps and solve a real exam question, just like toppers do. Okay, take a look at this question. A girl, a lamppost, speed, time. It looks a little complicated at first, I know, but trust me, with our new similarity toolkit, this is going to be a piece of cake. Let's just break it down together, step by step.
So the first thing we do is turn all those words into a picture. Look here. The tall vertical line, AB, that's the lamppost. The shorter line, CD, that's the girl. And the line on the ground, DE, is her shadow. Now, do you see it? We have 2 triangles here. The big one, ABE, and the small one inside it, CDE. Spotting these 2 triangles is the most important part.
Step 1. Let's prove these 2 triangles are similar. And we're going to use our super fast AA shortcut. Angle B and angle D are both 90 degrees, obviously, since the lamppost and the girl are standing straight. And angle E, well, that angle is part of both the small triangle and the big one, so it's common. That's it. 2 angles are equal, so we've proved triangle ABE is similar to triangle CDE. Easy peasy. Okay, now that we know for sure they're similar,
we can use their special superpower. Their corresponding sides must be in the same ratio. This means the base of the big triangle, BE, divided by the base of the small triangle, DE, is going to be exactly equal to the height of the big triangle, AB, divided by the height of the small triangle, CD.
And now for the final step. Let's just plug in the numbers. The lamp post AB is 3.6 meters. The girl's CD is 90 centimeters, which is 0.9 meters. Always be careful with the units. She walked for 4 seconds at 1.2 meters per second, so that distance, BD, is 4.8 meters. We're looking for the shadow, DE, so let's just call it X. So our equation is 4.8 plus X all over X equals 3.6 over 0.9.
And when you solve that simple little equation, ta-da! The length of the shadow, X, is 1.6 meters. See? That scary-looking word problem was solved in just 3 simple steps, all because we understand similarity. You've totally got this.
Fantastic work, everyone. Now, before we finish, let's do a super quick final revision. Think of these as the most important points to keep in your mind right before you walk into that exam hall. Just remember these 3 simple things. 1, all congruent figures are similar. 2, Thales theorem, or BPT, simply means that a parallel line divides the other sides in the same ratio. And 3, your magic toolkit for proving triangles are similar is AA, SSS, and SAS. That's the whole chapter in a nutshell. And finally, I just want to say this to all of you. You have prepared so well, you understand these concepts, you are absolutely going to do great in your exam, so walk in there with confidence. Best of luck, my bachon.